in which the expertise from other areas of civil engineering are also required. Number 3, I would like to share during my course of a presentation what are the various different areas on which somebody can do research. Finally, I feel that is the mandate of this faculty development program. Definitely, we'll be sharing our presentation. You can share this with your students, with your scholars, and you can learn in the process. So most important of all, which I consider is that what are the areas in which one can do a research, one can get a PhD, an area in which an MTech student can do a project work, how interdisciplinary research is possible considering sustainability in payment systems. So basic concept is that payment is a system that you have to understand. Because I have seen researchers calling in the name of payment engineering, but working in materials. So I don't consider that as a payment engineering. Payment is a system as a whole, consisting of different layers, different materials. So therefore, the performance of payment system is a little complicated. According to me, the most complicated civil engineering structure is a payment system. I'll tell you as why it becomes complicated. As you move along, you'll understand that. We talk about these payment systems. I always try to start my lecture with a quote from John F. Kennedy, which says that it is not the wealth that built the roads in US, but it's the roads that built our wealth, which means the country's economy can go up several times if you have a good quality roads. I always tell that the culture of the people will be known if you go to any country of the world. Once you land and come out of the airport, and if you see the quality of the roads, that quality of the roads will tell about the culture of the people. So that is a very simple litmus test, which you can know to understand the culture of the people of the country. But the bottom line is that if you have a good quality roads, the economy of the country will grow several folds. So if you want to achieve this road that can bring in better economy, what are the issues and concerns here? India has around 62 lakh kilometers of road, 6.2 million kilometers of roads. This we should understand. As a civil engineer, if somebody asks a question, or as a teacher, if somebody asks you a question, you should know the length of the roads in the country is around 62 lakh kilometers. After these 62 lakh kilometers, the national highways is only 1,36,440 kilometers. State highways, 1,76,818 kilometers. But majority of the roads in the country are 59 lakh kilometers of the road. So you understand that roads of different categories are available. All these roads do not carry the same volume of traffic, which means the sustainability as far as these categories of roads are concerned is different. In terms of material requirement, in terms of conservation of material, in terms of performance, all are different with respect to different categories of roads. The major point that you should understand here is that more than 59 lakh kilometers are other roads, which can be a major district road, it can be a minor district road, it can be a village road, it can be a project road, it can be so many other roads which are not expressways, national highways, and state highways. But these national highways, which constitute less than 2% of the country's road network, carries more than 40% of the traffic. Always, you remember, budget is limited, funds are limited. So when you talk about a sustainable payment system, I expect the payment to last longer without major maintenance. There's a very clear relation between the riding quality of the payment and the vehicle operating cost. As the road becomes from very good to fair to poor to very poor, every one of you, including you and me, are spending more and more on petrol, more and more on engine oil, more and more on spare parts. So tire life, tire cost, so maintenance cost. So the cost goes up exponentially as the road condition becomes from good to fair to poor. So we want all roads to be good. So that becomes the issue. So how much will it cost to construct 1 kilometer of a 4-lane highway or a 6-lane highway? A construction cost of a 4-lane highway can be anywhere between 10 crores to 12 crores per kilometer. The cost of constructing a 6-lane highway expressway can be anywhere between 15 crores to 20 crores per kilometer. Now you can multiply the length of the road by the cost which I am talking about. So that is the investment that we have made on the road infrastructure. So now the question arises, if I have limited money, where should I invest the money? National highways, state highways, or the roads? Obviously, the answer is invest on national highways because they carry more than 40% of the traffic. So what are the implications of this? By investing more and more on national highways, we are neglecting state highways, we are neglecting the district roads, we are neglecting the village roads. With the result, people from the villages move on to the towns, people in the towns move on to the cities, and the cities get more and more congested, and that we are creating an indirect problem. So when we talk about the economy, what is that I'm talking about? One is economy in numerical terms in terms of money. The second economy which I'm talking about is the social economics. So when you talk about the economy in social terms, what are the benefits of providing an all-weather road, all-weather in the sense, motorable all through the year? If you provide an all-weather road to a village, then what are the benefits? The benefits in terms of for the villages are in terms of improvement in education, improvement in the healthcare, improvement in the value for the agricultural produce, animal health improves, their people health improves. Therefore, the benefits are social benefits. We cannot put a numerical value for that, but definitely the country as a whole develops. Therefore, if I invest 1 rupee on a national highway, what are the benefits? Benefits are in terms of reduced vehicle operating cost. But I invest the same 1 rupee in a village, you are uplifting the life of the people. In other words, you are improving the quality of the life of the people. I feel the bottom line is that. It's not that people should fly fast, ride at 200 kilometers per hour. No. The happiness of the people is what matters. Provide an all-weather connectivity. See as how the quality of the life of the people in village improves. The agricultural produce improves, education improves, healthcare improves, buses fly to the villages. Therefore, it's a win-win situation. But you cannot quantify them in numerical terms. But for these 55,000 kilometers of national highways, we are going to spend nearly 6.26 lakh crores. You can put the zeros and count how many zeros are there. Or as a civil engineers, are we investing this money on any other sector of civil engineering? No. Huge investments are being made for the road sector. That is one part of the story. Therefore, the bottom line is money is not an issue now. And most of the projects under national highways are taken up under the public-private partnership. We talk about public-private partnership. A private concessionaire will come. He will take over. We give the land free of cost. He constructs the roads. He maintains the road. He also collects the toll. How much is the toll one can get? We find that the toll collection can go anywhere from between 10 to 15 lakhs to even 1 crore per day. 1 crore per day on some of the highways. 365 crores is the toll revenue alone in 1 year. Imagine 20 years, 25 years concession period one can have. How much money we are spending on the construction? How much money we are spending on maintenance? What is this influence of the quality of the road on the vehicle operating cost in terms of travel time, in terms of travel cost? So this also need to be quantified. But the problem is not that. Where is sustainability? That is a question that is being posed at this point of time. I have money. But the major problem that we are facing in the country today is non-availability of the materials for sustainability. There the problem starts. I'll take you over what are the issues here. We have beautiful highways. These are Ahmedabad Vadodara Expressway, 4-lane highway, expressway being converted 6-lane later. So this is something that we are able to see, beautiful highways. Earlier we used to say, go to other country and see good quality roads. We are able to see good quality roads even in India. The issue is that the road is brand new. It is smooth, comfortable, no cracks, no distress. How long will it last like this? Will it undergo deterioration? Yes, it will undergo deterioration. Why? With a repeated application of traffic load due to climate, due to environment and many factors, this pavement like this will undergo deterioration. It will develop rutting, it will develop cracking. So how do you ensure that the pavement lasts longer? That is the first challenge before us. When I construct a pavement like this, I expect the road or pavement to last for 15 years or minimum 20 years without a major maintenance. Does it last? No. There lies the issue. How to ensure or construct a sustainable pavement? That is a challenge before us. Even when you talk about concrete pavement, Yamuna Expressway is a concrete pavement. Now you know a pavement can be bituminous, a pavement can also be a concrete pavement. Is concrete sustainable? Mostly yes. Will it last longer? Yes. When this pavement can last for 20 years, this can last for 30 years. Then construct all as a concrete pavement, 30 years. Will it last? May or may not be. There are issues and concerns here. So the question arises at this point of time is that what is the aggregate consumption material requirement if I want to have a bituminous pavement or when I want to have a concrete pavement? That's the first question. We'll answer all these questions. Even in the case of a village road, we are able to construct a good quality rural roads. Thanks to Mr. Vajpayee, he started this Pradhan Mantri Gram Sadak Yojana, PMGSY. We are able to construct better quality rural roads in the country. So the question arises at this point of time, should the rural road be bituminous? Can it be concrete? Are all the roads be bituminous? Are these sustainable? That's the issue. Remember, once you construct a road like this, a blacktop or a concrete, this pavement will warrant maintenance. This will warrant maintenance maybe in the 10th year, 15th year, 20th year, 25th year. So maintenance becomes important. So when I want to spend, now nearly we are spending about 50 lakhs to 75 lakhs per kilometer of a rural road, single lane, 3.75 meter, 1 kilometer. We spend anywhere, it varies from state to state. I think generally it's around 50 lakhs rupees per kilometer to 75 lakhs rupees per kilometer, depending upon the state and other issues. So what is the sustainability we are talking about now? How I want to construct roads like this for the entire 62 lakh kilometers. What are the issues and what are the concerns? When I talk about sustainable development, we should meet the needs of the present without compromising the ability of the future generations to meet their own demands, which means if materials are available, if I construct roads like this, subsequently, as the traffic volume increases, because the population increases, traffic vehicle ownership increases, traffic volume increases, a single lane road will become a 2-lane. 2-lane will become a 4-lane. 4-lane will become a 6-lane. 6-lane will become a multi-lane. So if you consume all the available material now itself, what will happen to the future generation? Will they be able to get aggregates? No. That is where we should have a rethinking at this point of time. Thanks to Dr. Praveen Kumar that he brought in this course, a faculty development program, wherein we create an awareness of sustainability engineering. How do you ensure that the payments or the civilian structure is sustainable? Even in the case of a payment, sustainable payment, it refers to a system characteristics wherein we have to achieve the engineering goals. What are the engineering goals? A payment should be able to offer you smooth, comfortable, and safe riding surface. That's all finally you need. If I ask you, do you need a bituminous pavement? You need a composite pavement? Do you need a concrete pavement? You say, I am not worried what you are worrying. What I am interested is that a smooth riding quality, a comfortable ride. a safe ride. That's what I'm looking for. Secondly, when I want to construct a pavement with this, how do I preserve this with the respect to the surrounding ecosystems? You cannot find suddenly a concrete road among a jungle where everything is green. Can I have a green highways? So our highways should merge with the ecosystem. Thirdly, you should use financial, human, environmental resources economically. So just because aggregates are available, you cannot keep on using indiscriminately, constructing highways more and more and more. That is not sustainable. What are the environmental problems that we are creating? For example, a hill is there. You break the hill, get the aggregates, construct the road. So at a later stage, when you go for, if you want you to show to your grandchildren, there will not be any hill. What are the implications? Then there are problems of this change in the environment, ecology, climate change. Because of this, there are so much of damages that we are causing. Let us look back and let's see what damages that we have caused, how to ensure that the environment is protected. Finally, it has to meet the human needs, health, safety, equity, employment. It should be comfortable. And bottom line is happiness. If you ask anyone, what is that you need at the end of the day or in your life? Everybody will say, I need only happiness. It's not the money that brings happiness. The mental happiness has to come by the living that we make. That again, it was upon a good health, safer living, equity for among the road users, employment, and comfort. All these makes a life simple. So in all our research, my vision, mission, and mandate is that the research or the engineering work that we should do, or we have been doing, or we should do, should finally improve the quality of life for the people, make the life happy. How to make it happy? That is what we have to talk about in sustainability engineering. For example, how much quantity of aggregates are required for the construction? If you want to construct a 4-lane highway, we require nearly about 8,395 metric tons of aggregates for 1 kilometer of a national highway for a 4-lane. When it becomes 6-lane, it becomes 14,000 metric tons. Even for wet mix macadam, I require 10 and 21 metric tons, 21,000 metric tons. Now I told the length of national highways. Imagine you want to convert them into 6-lane, convert it to 8-lane. Do we have these aggregates? That's where the bottom line comes. No, we don't have good quality aggregates. Maybe that in South India, we are a little more comfortable. We are able to get good quality aggregates. But you move further and further to the north or move towards the northeast, you don't have good quality aggregates. So the sustainability engineering, when I talk about, number one, it should ensure reduced aggregate consumption. So this is the bottom line. Not only for the initial construction, with the design life of 20, 30, 40, 50 years, the pavement should warrant lesser aggregate. That means it is sustainable. How to ensure that? That's what we will see now. If you look, these are from the World Bank report, wherein about the Indian road construction industry, they publish that the quantity of material required for a low growth scenario, aggregate is 170 million ton annually. It is required. If the country's economy blooms, if you want to construct more than 40, 50 kilometers of national highways every day, in that case, our requirement of aggregate will be around 450 million tons. Bitumen 4 million tons, cement 17 million tons, steel 3.28. Do we have these aggregates? Never, no. Therefore, money is available, projects are on the shelf. But when I want to translate the design into a reality in construction, I don't have good quality material. Even for initial construction, leave alone maintenance. So the question is that how do you ensure a sustainable pavement system with the available materials? That is the challenge before us as a civil engineer. We find that we require about the 170 to 450 million aggregates per annum. So we are one hand, creating an environmental problem. More and more aggregates are being consumed just because they are available. Remember, all the aggregates which I'm talking about may or may not meet the specifications. All aggregates will not meet the specifications in terms of physical properties. It can be abrasion, last one is abrasion value, aggregate impact value, elongation index, flakiness index, or the shape factors, specific gravity, soundness test. Many may not even pass. In that case, what is to be done? On one hand, aggregate non-availability. Second is available material may or may not meet the physical requirement. For example, if you go to Northeast, majority of aggregates may not meet the requirement of impact value, may not meet the requirement of water absorption. So these materials, they may meet some specifications, they may not meet all specifications. In that case, I call them as marginal materials. So the research area for some of the teachers or students who are attending the course is that how to make use of these marginal materials in road construction. Because aggregate is not available, whatever available material, if it is not meeting specification, how to make them suitable? That is the challenge. The third challenge before you is that can we produce artificial aggregates? I think this is a good area for research. Can I make an artificial aggregate from industrial waste and other products? This again, somebody has to explore. For constructing a 60 kilometer of a road improvement, we require nearly about 20 lakh tons of aggregates. And many of the states don't have quarries, and many of the states have banned quarries. And if you want to transport the aggregates for 200 kilometers, the cost of the diesel requirement will be of the order of 180 lakh liters for transportation alone. So this transportation cost adds to the cost of the material. So the cost of the material at the site is much more than the cost of aggregate alone, because you are spending quite a lot of money on transportation. So this again opens up another area of research. Is it necessary that I should transport the material over longer distances? No. Can I use locally available material? Yes. That is again another area of research. You'll be interested to know that for construction of the airfield runway, roads in Andaman and Nicobar Islands, aggregates are being transported by ship from the mainland because the aggregates available in Andaman and Nicobar Island are not suitable or not meeting the physical requirement. Is this sustainable? No. That is what I am bringing in as an issue. So the bottom line again is that you should be able to make use of the locally available material. Transporting material over longer distances, causing more damage to the pavement, increase the cost of material is not sustainable. So how to make it? We'll talk about as how to make the locally available material suitable for construction. That is a challenge before us. I always enjoy taking up these challenges and finding a solution. There's nothing that is impossible. We should make it possible. We are all civil engineers only for that. Not to say that this material is not suitable, we cannot use. No. How to make the material suitable? You tell that. That is engineering. That's why we are now coined the words. We don't call it as stabilization. We call it as engineered soil. We don't say that performance-based bituminous mix design. I say engineered mix design. So engineer should make the material property suitable for construction. Whatever material you give it to me, I will make it suitable. That is what the research area, I feel researchers should work in this area. Sustainable pavement when we talk about in the context of pavement refers to some of the characteristics like it should meet the traffic. It should offer good riding quality. For example, the riding quality of the pavement can be represented or expressed in terms of roughness. For example, if the road is uneven, you add up the sigma of all the undulations along the longitudinal direction. In a simple, coarse, crude language item. There are different methods by which we can measure. A laser can be mounted on a vehicle. The laser measures the distance from the vehicle chassis or the body, mudguard, to the pavement surface. It measures the distance between the vehicle front to the pavement surface. It accumulates the undulations and then tells in terms of roughness. So this pavement, it can be called as a roughness. It can be called as an international roughness index. how much the value will change. A very good road can have a roughness less than 1500 millimeters per kilometer. If the roughness is around 1500 millimeters per kilometer, then you feel comfortable. You can sip a cup of tea in your road. So that is comfortable. Less than 1500, you can easily do that without the tea spilling on your shirt. I call it a smooth surface. Glass roughness is 0. You can imagine that, 0. A very bad road can have from 2500, and with the passage of traffic, this roughness value will increase from 2500 to 3000 to 4000 to 5000 to 10,000 to 15,000. So it keeps on increasing. As the roughness increases, the vehicle operating cost also increases several fold. So what do you need finally? I need a good serviceability, good performance. Or then what else you want? I don't want to see cracks in the pavement. I don't want the pavement sheared and rutted on the surface. Okay, fine. So now you quantify it in terms of riding quality, performance. I'm talking about performance of the road in terms of riding quality. You define the performance in terms of distresses, cracking, rutting, patching, pothole, shear deformation, many things. There are many other distresses out there. So it can be distresses. Third can be, I talk about the comfort, how comfortable you want. So finally, what you expect is that I am not worried what you are burying. I want a smooth surface, a comfortable surface without distress, a good riding quality. That is the basic requirement of a road surface. If you want to achieve this, what should be the pavement structure? So finally, we should go back to the pavement, not from pavement to the performance. I am coming to the reverse engineering. What is reverse engineering? I want a performance. If I want a performance, what should be the pavement design? What should be the pavement thickness? What material should I use? So I am not coming from the material to the design to the performance. I am coming from performance to the design to the thickness and to the materials. Here comes the challenge. What thickness will ensure you a satisfactory performance? How optimally you can utilize the available resources? There are two factors here. One is project cost. Second is materials. As I just now mentioned, material availability is a major challenge. And I also told at the beginning that funding is limited. When I told about the public-private partnership, this public-private sector will bid for a project with a national highway because he will get a toll revenue. I told toll revenue can be on 1 crore per day. Will the private sector construct a village road? Never. Why? They don't get a toll. Then how can they manage? How can they survive? Therefore, other than maybe 50 to 75,000 or 1 lakh kilometer of national highways, the balance of 60 lakh kilometers of roads ought to be designed, constructed, maintained by the government and government only. When the government wants to do the sustainable pavement design and construction, when materials are not available, how to do that? That is where the researchers should come out with findings of optimal utilization of the resources. Number one, it reduces the aggregate consumption. Number two, it reduces the project cost. When you want to use a locally available material, then you can definitely reduce the project cost. I can give an example. I have a road. I want to construct a village road or a road around a village or road to a village wherein the CBR of the soil may be 4. I find some quarry little away, maybe 10 kilometers away. I get a quarry where the soil can give me a CBR of 10. At 20 kilometers away, I get a third quarry, a second quarry, where the CBR is 20. Now you know the CBR for a given traffic that dictates the thickness of the pavement. When I want to make use of the locally available material, the thickness requirement is, say, for example, X. When I get a 10% CBR instead of 4% CBR, when I get a 10% CBR, the thickness can reduce by 1/3. So X minus 1/3 of X, it decreases 2/3 of X. When I bring a soil which is 20 kilometers away, then the thickness reduces by half. Instead of having 1 meter thick pavement or 500 millimeter thick pavement, I can bring down the thickness to 250 millimeter. Is this sustainable? Yes. Is there any other solution in this point of time? Yes. What is the solution? Can I make use of this locally available soil by improving its properties? Yes, that is the solution. I am not transporting material over longer distances. I am improving the locally available material through some there are different techniques. We'll see what are those techniques. So that is what will reduce the aggregate consumption and optimal utilization of the resources. Thereby, we are conserving the natural resources. At the same time, instead of having now, there are different choices here. I can construct a pavement with a 4% CBR. I can construct a pavement with a 10% CBR. I can construct a pavement with a 20% CBR. I can construct a pavement with this 4% CBR stabilized. That may be the fourth choice. I can stabilize this 10% CBR. I can stabilize the 20% CBR. So there are 5, 6, 7 options are available. Now the challenge before you as a student, as teachers and students is that how are these pavements perform? When will they become very good to poor? Fair. When will they become poor? So that means you have to predict the performance of this pavement. So in a nutshell, in a period of 20 years, what is the maintenance requirement? So I'm talking about the initial construction cost. I'm talking about the maintenance cost with the design life. Because of the bad road, your vehicle operating cost also goes up. If you add up everything, initial construction cost, maintenance cost, vehicle operating cost, all the costs put together, other costs as well, it's a life cycle cost. So the challenge before you is making use of locally available material. Number 2, modifying the properties of the material. Number 2, 3, using that computer material property for the design thickness. Number 4, predicting the performance of the pavement with these alternate designs. So now you'll understand there's nothing like a one size fit all design. There are number of possible alternate designs available which can ensure sustainability. So you have to think in terms of benefits, in terms of cost, in terms of time for construction, in terms of environmental benefits. Only then you have to choose the appropriate payment type. What we do today, whichever contractor quotes the lowest will get a project. Is sustainable? Need not be. So we have to bring in sustainability in the award of work in the tender conditions. That is another point that you should consider. What are the strategies for improving the sustainability? Number 1, I was talking about the materials that are available. Or secondly, I also told that how to improve the material and its properties. Can I improve the material properties, performance? Yes, I am improving the material performance. How do I do that? I take the locally available soil. I test the soil and its properties. When you test the soil, what is the property that you test? You do a wet sieve analysis. Never ever do a dry sieve analysis for a soil. Always do only wet sieve analysis. Look at the fines passing through 75 micron, number 200 sieve. That is a culprit in most of the cases. Maybe the liquid limit is more, plasticity index more, free swell index is more, proctor density is low, OMC is high, CBR is low. So we know that once you test the soil, I know what is the lacking property. For example, the soil has got too much of fines. That means percentage passing through 30 micron is more than 35%. Will the soil perform better? Definitely not, because fines are more. Is it suitable? No. Can I improve the performance? Yes. Can I do stabilization? Yes. So now, if you do that stabilization, you should be able to predict what will be the performance of a material which is improved. Second, you have to characterize the material. Find out the property of the material after it is improved, which means you have to do a mixed design. Third, in laboratory, we can do anything and everything. Take 1 kg of soil, 2 kg of soil, 5 kg of soil, precisely measure the water content, add it, mix it by hand, compact it, and then get a density. But to go to the field, you may have to construct 1 lakh cubic meter of soil compaction. How to ensure OMC? That is the issue. How to ensure compaction, that becomes an issue. So one point which I have not so far talked about is quality of construction and the performance. Many times material is good, but we miserably fail in construction quality. So construction quality dictates the performance. So your design may be excellent, your material property characterization may be excellent, but we miserably fail in India. Even today, we are not mastered that. Quality is poor, with the result the pavement prematurely fail. That is improving the material performance. The second issue is, how do I reduce the bituminous layers? If you look at the pavement system of a different layers, the top layer is a bituminous layer. The bituminous layer costs nearly 40% of the total pavement layer cost. If you want to reduce that cost, reduce the bituminous layer thickness. Now, I have gotten old pavement, which is cracked, which has rutted, which has failed. What is the solution now? I can provide an overlay over that. Can I reuse the material? Yes, you can reuse the material. Will it reduce the virgin aggregate consumption? Yes, it will reduce the virgin aggregate consumption. So therefore, a sustainable solution will be reduce, recycle, and reuse the material. So second sustainability in pavement engineering is use of more quantity of reclaimed asphalt pavement material, which is a RAC. There are used materials, industrial waste. There can be other ways like the tire rubber used at car tires, truck tires. They can be modified, crumbed, and then made as of in bitumen, as layer as a crumb rubber modified bitumen. With the result, you'll find the performance improves. It also have got an importance on the environmental impact. So thirdly, by doing this process, by reusing the material or stabilizing the material, I am reducing the transportation of the material. I'm using low quality, locally available material. Maybe that they may not meet the requirement of physical properties, but accordingly, the design has to be modified. We can also do a recycling, which can be in place or central recycling, but also warrants plant modification. When you have a central plant, wherein you mix the material, you have to modify the plant requirement. So therefore, the challenge before us as civil engineer is how to use these alternate materials, how to use the industrial waste, how to use the marginal materials in construction, how to characterize the material, how to use that characterized material property in the design. Will it be durable? What will be the life? How many times the pavement will warrant maintenance? What is the life cycle cost? So there are different solutions possible, but we have to take it as a challenge and then predict the performance. Always check. The performance is ensured, which means the material is durable. We should have the permanency in the strength should be retained. So it should never be compromised about durability. You can say get some strength, initial strength. Does not mean the performance will be good. We talk about sustainable road infrastructure. You should consider in terms of stabilized subgrade or engineered subgrade. Subbase, base. You can make use of locally available material. You can make use of locally available aggregate. So one is going by the book. You take the book, code or any specification, it tells the physical properties, mixed properties, you design the laboratory and you assume that this will be translated directly in the ground. There only we are failing. Many times what we do in theory, we will not be able to practice because of many issues of constructability. Field issues are different. And I want a pavement, as I know, a pavement which is subjected to more and more traffic is subject to more and more repeated application that is subject to more fatigue. That means I need a material which can take repeated application of traffic load repetitions without crack. And many times what we found is that in case of highways in tropical countries like India, when the temperature varies significantly in a day, for example, the pavement temperature is around 25 degrees more than the air temperature. It's summer, maybe now. Pavement temperature, air temperature may be 40 degrees, 45 degrees in Rajasthan, other places. So the pavement temperature will be 70 degrees plus. In winter, Rajasthan goes to 0. So will one bitumen be able to take care of this extreme temperature from 0 degrees or minus to 70 degrees? No. So when there's a temperature variation and the pavement is subjected to a higher traffic loads, overloading trucks, higher tire pressure, we find the tensile strains develop at the top, with the result the pavement may crack at the top. We always feel that it's only bottom of cracking that takes place when the pavement bends, but it's a top-down crack that occurs because of climatic factors, overloading, higher tire pressure. But what are the issues here? Once the pavement cracks, water will enter. When the water enters, it's trying to strip off the aggregates in the bitumen and potholes are formed. It affects the riding quality. It makes the road unsafe. Then, and when the mix is not properly designed, the material will shear off along a particular wheel path we call by the term rut depth. So there can be a top-down cracking, there can be a bottom-up cracking, that can also be rutting. So we have to select the appropriate material for the bituminous layer, which will not rut, which will not crack. Can I use alternate materials? Yes. We can use bitumen, foam bitumen. We can use emulsion. We can use the reclaimed asphalt pavement materials. We'll see what are they. And more importantly, whatever you try to do, the performance of the pavement is dictated by drainage. It's always said there are 3 factors that contribute to the failure of a pavement. 1 is drainage, 2 is drainage, 3 is drainage. If you take care of drainage, most of the failures of the pavement can be taken care of. So how to ensure surface drainage as a subsurface drainage is a challenge before us. The last assumption question before us is that for sustainability is that a perpetual pavement, a deep strength pavement, which means I want to design and construct a pavement which should last for 50 years, 50 years without major maintenance. Is it possible? Possible. Not that it is possible. According to me, nothing is impossible. Everything is possible. How to do that? That is what you should learn. Go through, browse about perpetual pavement, what are the issues, what are the concerns, how to design a perpetual pavement, such that the design life is 50 years. So these are challenges for sustainable road infrastructure. So we require, as I was mentioning, huge quantity of aggregates are required for construction as well as for maintenance, both for new construction as well as an improvement of an existing pavement, which means, as I was mentioning, we should consider alternate materials. In the case of new pavements, alternate designs. Supposing if you are working in NHAI, or working in NRID, or working in the state PWD, a consultant gives me 5 different designs. One with a soil of 4% CBR, another with a soil of 10% CBR available at 10 kilometers away. Third design is 20% CBR from a quarry 20 kilometers away. Fourth can be 4% CBR stabilized and made 10%, and that is the design. Fifth can be this 10% CBR is stabilization converted in 20%, and then he has given a design. Now there are 5 designs. You should be able to suggest which design will work better, not only based on the initial cost, but you should be able to say which design is likely to perform better, which design is likely to give you a rut-free pavement, a crack-free pavement, a good riding surface. So that is a challenge. That is sustainable. Is it sustainable? Is again you have to give a value to that. So the challenge before you is how to predict the performance of alternate designs. How to predict when the pavement will warrant a maintenance. What are the maintenance treatment or what the cost? You bring back all the cost to a base year and then compare. What I mean here is that these payments with a CBR of 4, 10, 20, 4 to 10 and 10 to 20 CBRs will perform differently. And it will warrant a maintenance. One may warrant a maintenance the 4th year, the 8th year, and the 12th year. Second may warrant a maintenance the 7th year and the 14th year. Third design may warrant maintenance only the 10th year. So you do the maintenance in different years. How do I compare these designs? Bring back all these maintenance costs to a base year by discounting these costs and then compare which design will result in the lowest life cycle cost. And as I was mentioning, construction quality plays an important role on the performance, and we need to collect the data as how they are performing so that we can develop an asset management system to decide whether a road has to be converted into a 4-lane to 6-lane or it has to be maintained in a better condition. Budget is limited. Always remember that. If the budget is limited, should I convert a 4-lane road into a 6-lane road and thereby increasing my maintenance cost? Next year, my maintenance cost increases because I added 2 more lanes. Budget is not there. Or should I maintain this 4-lane to a better condition so that next year also it will be good, which is beneficial. So we have to find the cost benefit analysis and asset management in this process. So to start with, the pavement can be of different types. It can be bituminous, it can be composite, it can be concrete. So again, I have been talking only about the bituminous pavement with a design of 4, 10, 20 CBR, or 4 to 10 CBR and 10 to 20 CBR. Now, I am adding more problems. We talk about different types of payments. When the payment type varies, your initial constraint cost will vary. Thickness will vary. With the time in which it deteriorates or rate of deterioration will change, which means its maintenance cost will change. Its rehabilitation cost will change. So you decide the payment. I don't say that concrete payment should be adopted. All the 62 lakh kilometers of road in the country should be concrete payment. I don't tell that. It depends upon engineering consideration. Many factors come into picture. Material, equipment availability, life cycle cost, sustainability considerations, also the type of contract. There are different types of contracts today. One is based on the bill of quantities. That's what conventionally we do it. The government agencies, they prepare an estimate, take levels, test some soils. They estimate what the quantity of material required. They call for a tender and award the work to a contractor. So what are the challenges here? The contractor will have 1 year defect liability period, a 2 year defect liability period. Afterwards, it's the government that has to maintain. That's a conventional design. Then we brought in alternatives, engineering, procurement and construction, EPC contract, wherein we have to do an engineering survey. You have to get the material, construct the material and give a longer performance guarantee. Now under public-private partnership, we talk about design, build, construction, and operation transfer. 20-25 years, you have to maintain the road, which means you'll bring better material, better constraint equipment, better quality control, you will ensure satisfactory performance. So the risk of design, quantity estimation is not there. It is your funeral. If you want, you can construct with the clay. I'm not worried. But you should guarantee me that the ready quality will not exceed 2,500 millimeters per kilometer for the last 25 years. So the concessionaire knows that if he spends less initially, he will spend more on maintenance subsequently. Some of the projects that are available today are what are called TOT roads, TOT projects, toll, operate, and transfer. Now roads are available for sale. If somebody has got money, 1,000 crores if you have, contact me. I will tell you where the projects are available. Road projects are available for sale. You can buy the project. What are the issues here? The project was not constructed by you. It was constructed by somebody else. Now you have to estimate what is the condition of the pavement today, what is the quality of the material that were used, how many more years the pavement in this present condition will last. For if I want to maintain this road, already constructed road for 20 to 25 years, what are the maintenance requirement? This again is a challenge. With different materials, different constraint quality, you have to predict the performance. That becomes a challenge before you as a civil engineer. Yeah, structural pavement, as I was mentioning, consisting of different layers, embankment, subgrade, subbase, base course, blacktop. This alone costs nearly 40% of the pavement layer cost. It distributes the road over a wider area. So stresses coming here are much lower. So any locally available material will be adequate in the lower layers. But I read a rich material at the top because it takes up the entire load that comes directly on it. Load then gets distributed in a trapezoidal form. But one thing which I have not spoken so far is that I'm talking about from the pavement. What is that I'm talking about? I'm talking about the subgrade, subbase, base, and blacktop. What of this embankment? Should it be an embankment? Need not be. It can be cutting also. But will this embankment properties influence the performance? Yes, yes, yes. If H is the height of an embankment, you should investigate the properties of the soil to a depth of 2H. If this is a clay soil, even if you put a steel plate, it will not work. If you have blackened soil, if you consider the pavement, it will not work. Therefore, a civil engineer should understand that the performance of the pavement depends upon not only on the pavement layers, but also on the supporting layer, which can be filled or can be cut. Anything can be there. Many times it can be clay soil. For example, a port connectivity project. The soil may be a marine clay. How to ensure the pavement will last longer? That becomes such a biggest challenge. So I always enjoy taking up the challenge, giving a solution, and seeing that your solution works in the field. I always feel that is a real pleasure that one can get as a civil engineer. Earlier, we were not adopting this alternate design because alternative designs were not approved by the Indian Roads Congress. Of late, we have introduced alternate designs. Choice one is in a pavement design, we consider two critical strain values. One is strain value at the bottom of the bituminous layer and the strain value on the top of the subgrade. If these values are kept within the allowable limit, your pavement performance can be infinite. This is too low, it can take 30, 40, 50 years. If this is too low, it can take 30, 40, 50 years. How to do that? That's a challenge. How are they related? When this strain value exceeds the allowable value, that is the bottom of the bituminous layer, the pavement will develop a fatigue crack from the bottom and the crack will propagate to the top. So this radial tensile strain is related to the cracking. This vertical convergence strain is related to the rutting and the pavement. The pavement will rut because if the strain value exceeds the allowable value. What should I do now? If you want to reduce the strain, what are the solutions? Solutions before you are, you can increase the thickness. Increase the thickness, strain values are decreasing. Simple solution. But what is the challenge? No material. When there is no material, the question of improving the thickness does not arise. What is the solution now? Improve better quality materials or improve the properties of the material that are already available or locally available. So that becomes the possible feasible solution. What is the thickness that are required for about 50 million strand axles? I require 200 millimeter thick granulous subbase, 250 millimeter thick base coats, 145 millimeter thick bituminous layer. This is what for a 50 million strand axles. Of the 62 lakh kilometers of road in the country, more than 59 lakh kilometers of road in the country will follow in this any other templates. If CBR is 10%, this is thickness. When CBR decreases, the thickness further goes up. So simple way of reducing the grade consumption is improving the strength of the locally available soil. Improve the strength of the subgrade. With the result, your thickness will reduce, the grade consumption will reduce, and when you improve the properties of the subgrade, your performance will be better. When the performance becomes better, your maintenance cost will become lower. Therefore, simple sustainable solution is improving the properties of subgrade soil. There are many methods by which we can improve that we should be able to teach to the students. What we found is that when you talk about a pavement like this, if it says that this is a modulus of this layer, I can call it a resilient modulus or a dynamic modulus or a fractional modulus, some modulus. If we say this modulus is E1, this is E2, this is E3, this is E4. E1 will be more than E2, E2 will be more than E3, E3 will be more than E4. So as the thickness goes, as the upper layer goes up and up, as it go up and up, the modulus value increases. But in the case of an inverted pavement, what I'm trying to do is that I am providing a cement treated base here. I am increasing stabilizing the subgrade. Because I have improved the subbase, improved the subgrade, thickness of the layer decreases. From 300 millimeters, I can bring down the thickness to 150 to 200 millimeters. I can reduce the bituminous layer thickness from 200 millimeters to 50 to 75. And as I was mentioning, majority of the roads in the country do not warrant a bituminous pavement with a higher thickness. You can easily go for the inverted pavement. What is inverted? If If you say E1, E2, E3, E3 becomes more than E2. Therefore, it becomes inverted pavement. I provide a strong subgrade. I have stabilized the subgrade. I am providing a cement-treated base. I improve the subbase. With the result, the thickness of layer can be broadly reduced. So another one solution is improve the subgrade, provide an improved subbase, base course of subbase. That is the second solution which I am bringing in. So we talk about sustainability. We should learn as how to bring in sustainability by reducing the virgin aggregate consumption, reducing the maintenance requirement in terms of material, in terms of cost. Both are possible by stabilizing the subgrade or by stabilizing the base or the subbase courses. So we brought that. This is a design catalog of the IRC. We say the cement treated base we can happen. What is the issue here? You should know the problem and you should also know the solution. Then only you are a complete engineer. So you shouldn't say that I am not knowing this. What will happen? What will happen is that this cement treated layer under repeated application will start cracking. So when it starts cracking, once it starts cracking, the crack will propagate to the top. So you should know that cement treated layer will crack. So I am providing an aggregate interlayer here, which will retard the appearance of cracking on the bituminous layer. If this layer is not there, the crack that occurs here will get reflected on the top. So there will be a requirement of a crack relieving layer. We found that we can go in for this layer will start developing cracks. So you have a cement treated base. This layer starts cracking because of tension at the bottom. So this crack initially will start because of deflection of the base course. So it's not a very strong concrete pavement. It's only cement treated bases or cement stabilized material. And this crack is a bottom up cracking phase 1 failure criteria. This will become, single crack will become double crack, will become more and more is the effective fatigue phase. And eventually the crack will become more and more. Now, you should know as a civil engineer, what modulus should I consider while designing the pavement? What modulus you consider the pavement is that you consider the pavement as like this, no cracks. This modulus you consider. This modulus under repeat application, once it cracks, it becomes more cracks and more cracks. It forms the modulus value will be like a granular layer. So consideration when it will crack, in which year it will crack, and what will be the effect of the crack on the modulus value, on the predicted life of the pavement, on the maintenance requirement, is something that research has to come in. More and more highways will be constructing like this cemented layer. You should be able to tell what is the optimal dosage of cement, what is the optimal strength that is required in that layer. You should know that the stresses are decreasing with the thickness. At that layer thickness, what is the strain value? For that strain value, at a repeat application, what should be the modulus of the base course? How that modulus value will change over a period of time? How to design the mix? So I am coming from the performance to the layer thickness to the material and predicting the performance. This is the way the engineering should move, not from mixed design to design construction and design to construction. No, reverse engineering only we should be adopted. In South Africa, they adopted the upside down, wherein above the cement treated subbase, they have a crushed stone base, which is called as a cushioning layer. This will prevent the crack from appearing to the bituminous layer. So crushed stone base can be considered to be a layer which will prevent the appearance of the crack on the bituminous layer. So the design catalog 3 can be, instead of the granular layer, I can go in for a stress absorbing membrane interlayer, SAMI layer, which is a bitumen impregnated geosynthetic layer. This also will return. So the next challenge before you is that, what should be the specification of this SAMI layer? Will it crack? What is the fatigue life of this? What are the specification of this? Now I have two choices. I have a granular layer, which I have showed here as a crushed stone base. So I provide a SAMI layer, which is better. When aggregate is not available, I can go in for a SAMI layer. How to introduce this? What is the fatigue life of this? This is again another area for research. So reflection cracking studies can be taken up by any MTech students or research scholar. Somebody can even be a PhD topic area, if you are looking for a PhD topic, this gets a good topic wherein you will be able to come out with an optimal thickness, optimal design, fatigue life prediction, and then come out with the design which will result in the lowest life cycle cost. This is a very good area for research. We also brought in a reclaimed asphalt pavement material which can be used in the design and construction. Old pavement milled material, I can reuse it again as a base course. If I use the material as a base course, how much is the material conservation that can be conserved? What is the benefit of this? So again, you should consider the material characterization in the design process. You should be able to predict the performance. You should estimate the maintenance requirement and the life cycle cost. So mixed design of a rack is again a challenge. So those of you who want to choose a topic for a PhD or MTech student, mixed design using the rack is another challenge which can be taken up as a project problem for the research. We brought in a cemented subbase, cemented base with an aggregated layer. This is a choice 5. I can also go in for a cemented base and a wet mix macadam granular base. This is again a choice. Now you realize that there is nothing like a single size, one design, single size fit all design. You can have number of alternatives with alternate materials, but the challenge is that what is the grade consumption for all the 6 designs? What is the design thickness? What is the performance? What is the maintenance requirement? What is the life cycle cost? So one has to come out first and then arrive at the sustainable design considering various alternate designs that are possible. You go in for a concrete pavement as well. Apart from the 6th, now the 6th, along with the 6th, this is the 7th challenge before you. I can go in for a concrete pavement also. A concrete pavement takes the load by a slab action. So even if the subgrade layers are weak, instead of increased thickness of the bituminous layer, I can provide a rigid structure. The slab after its wound takes up to the load. That is much, much better. Here again comes into sustainability. I'll give an example as how the material can be reduced. So when you talk about sustainable material, we need a material which will offer a higher modulus when compared to gravel. I can go in for a stabilized subgrade or engineered subgrade, subbase base. I call the stabilized base, stabilized subbase, stabilized subgrade as engineered subgrade. So when I talk about engineered subgrade, subbase base, you should be able to find what is this modulus. How much strains it can take up? Will it result in a reduced thickness? Will it reduce the thickness of the bituminous layer? Will it reduce the pollution? What are the savings in cost? So that is a challenge before you. When you talk about sustainable engineering, engineered material is that one side of the basket. Using the material, engineering material property, the design, construction, performance prediction is a challenge. Second, I already constructed the pavement. I want to make use of reuse the material. I want to recycle the material. How much I can recycle and reuse? So there are issues in equipment that are to be considered. In the case of reclaimed in a central plant, we are not able to add more than 30% of the reclaimed material because of many, many challenges. I'll talk about that. But in the case of cold in-place recycling, up to 85% or more reclaimed material can be used. So the bottom line here is that in case of recycling, sustainable pavement material is reduce, reuse, and recycle the material. I can give an example here. What are the benefits here? I want to design a pavement for a soil of subgrade CBR 10 to cater to 50 million standard axles. I require about 595 millimeter thick of a bituminous layer. If I want to make into a composite pavement or alternate inverted pavement, I can reduce thickness to 560. In this case, the rigid pavement is 650. But there are materials that are required in different layers. You'll find that aggregate requirement is the lowest, even though thickness is higher. It's lowest in the case of concrete pavement. Slightly increased cost of 3.23 crores per kilometer for a 2-lane when compared to 2.46. But this will last for 30 years. This may last for 25 years. This may last for 20 years. So the life are different, maintenance requirement are different. So instead of spending less initially, I would like to spend 80 lakh rupees more and then forget about the road for 30 years. So understand alternate designs will result in improved performance, reduced virgin aggregate consumption. Even a simple case, what you can think of can be stabilization subgrade. If a soil has got a 5% CBR, a locally available material, I can increase it to 10% CBR, improving either by adding lime, cement, or any other material that a number of commercially available stabilizers are available. I can increase from 5 to 10. By increasing 5 to 10, I can bring down the binder layer thickness from 140 to 105. What are the benefits? I can reduce the cost of construction from 3.2 crores to 2.91 crores. So straight away, I save nearly 29 lakhs per kilometer. So this you can think in terms of 59 lakh kilometers of road. By improving subgrade, you can bring in substantial benefits in terms of virgin aggregate consumption, initial costs. Not only that, this pavement will be subjected to less moisture-induced damage. When there is a less moisture damage, your performance will be better. When the performance becomes better, its maintenance cost will be lesser. The aggregate requirement for maintenance will also be lesser. Therefore, it's a win-win situation. I'm not only reducing the aggregate consumption, I'm also not only reducing the cost, but I'm also improving the performance. So simple solution for sustainable pavement engineering is improving the properties of the subgrade and the lower layers. In the case of low volume roads, that I want to provide nearly 325 millimeter of a granular base, I can bring down the thickness from 325 to 200 millimeter by stabilizing the base. The earlier case I told stabilizing subgrade from 5 to 10. Now I'm talking about stabilizing the base course of from 325 to 200 to 250. You'll find that cost savings are 6.5%. The aggregate savings are around 2,113 cubic meter of aggregate for a 7 meter wide pavement for 1 kilometer. So substantial benefit can be brought in. Number one, by improving the fill and subgrade. Secondly, by improving the base course. These are the conditions of the road before, these are the conditions of the road later. This road will last for 20 years or 30 years without maintenance. That is what we are looking at. So composite pavement is something that I have been talking about. If you look at IRC, that is 7, it talks about different designs of a cement treated subbase. Cement treated subbase and a cement treated base, we can result in lower thickness, or we can go in for a cement treated base alone. So alternate designs are possible for a given soil type and for a given traffic. Now you have to consider these alternate designs. As a teacher, you should teach all these to your students. Students should not go with IRC 37 one design. Students should know alternate designs are possible. They should know what are the benefits in terms of aggregate consumption, in terms of improved performance, in terms of life cycle cost. If the students who are graduating from your institutions know these basic concepts, then they will be successful engineers in profession as well. For example, for a 70 to 100 MSA, if you look at their designs, instead of granular subbase, if I provide a cement treated subbase, the matrix macadam which I'm providing will serve as a crack relieving layer. Lowest aggregate consumption thickness is drastically reduced. You find that the material requirement for a single layer, a cement is spread, pulverize, compact, up to 250 millimeter, grade it and cure. So it is possible for you to do this in a single operation. Up to 200 millimeters, 250 millimeter, you can compact in a single layer. But you should know that different equipment are available, are required. One as a spreader, we have to pulverize the material. We should compact the material. The type of pad foot roller has to be chosen. What is the benefit of pad foot roller with respect to a conventional roller? The student should know how to grade it, what is the function of grader, how to compact, how to cure, what is the importance of curing. All these the students should know. So when you teach construction, all these concepts should be known. If a failure in any of these 6 steps will ensure early failure. If dosage of cement is not okay, or it's not uniformly spread, or not fully pulverized, or the compaction is inadequate, or the grading is poor, the chamber is not adequate, or the curing is poor, then the performance will be bad. What do you say? Stabilization has failed. But stabilization has not failed. The quality of adopted in stabilization has failed. So normally we attribute the failure to the technology. No, both are different. So quality of construction plays an important role. In the case of NH 344A, 10% CBR for 90 MSA, they design the pavement such that for SCBR, the DBM requirement is 5 lakh tons, wet mix macadam is 7.2 lakh tons, 48,000 tipper rounds, and how much you can estimate the amount of diesel being consumed and the pollution that we create. Instead of this design, by conventional design, I can go in for a organic design of the cement treated subbase. When you go in for cement treated subbase and then work out what the thickness strain values and then design the thickness, you'll find that the thickness can drastically be brought down. From this thickness of 200 plus 250, I can bring to 200 plus 150. Is a 125 millimeter dBm, I can bring down to 85 millimeter. So if the strain values are ensured to be within a allowable limit, with the result, you will find that I can save nearly 60 lakh rupees per kilometer. You can imagine the money that you can bring in. Will it perform better? Yes. Is it sustainable? Yes. So therefore, 6 million rupees savings per kilometer is a huge sum that can be brought in. If you even look at the economic analysis, I can show the details of the DC, DBM, wet mix macadam, granular subbase. There's a reduction in the layer thickness, reduction in the life cycle cost, increase the payment life, lesser maintenance cost materials. So huge quantity of aggregate can be reduced, consumption can be reduced, and that is sustainable engineering. I was talking about recycling. Recycling is one of the alternatives that are considered. A pavement which is excellent initially will start deteriorating for the day it is open to traffic. A pavement which is very good here becomes good, becomes fair, it becomes poor, it becomes very poor. When should I maintain the road? Remember, the initial 70% drop in the quality occurs here. The second 40% drop in quality occurs 12% of the time. So it becomes a rapid deterioration of the quality of the pavement. If you do the maintenance here, it may be costing less than a rupee. It may cost maybe 1 or 2 rupees. It may cost 4 to 5 rupees. When you come here, it will cost 100 rupees per kilometer. Therefore, the cost increases. The more and more you delay, more and more will be the maintenance cost. If you think that this year I don't have money, next year I can do. No. This year you can do it at 20 rupees. Next year, the cost will become 40 rupees. So if you can do 5 kilometers today, I will be able to do only 2.5 kilometers next year with the same money. Can I recycle the material? Yes. At this point of time, the pavement is fairly good condition. You can recycle the material. Benefit, the performance of the quality of the pavement improves. It becomes very good initially, like a new pavement. So the rate of deterioration, look, this is the rate of deterioration. This stabilized pavement will perform much, much better. When it will reach a fair condition, say 40, it assume that it reaches the 12th year. The next condition may be after 20th year. 8 years or more, only later it will warrant maintenance. So recycling is another sustainable solution here. When the riding quality is poor, pavement distresses are more, friction is less, excess maintenance requirement, unacceptable user cost. You can go in for a recycling here, but you have to select the recycling method. I can mill the entire material, which is called the full depth reclamation. I can mill only the bituminous layer. I can mill the bituminous layer and the base course. That again an engineering solution. So that you have to mill the material and reuse it again. Find that after you mill the material, you can reuse it again. There are different types of recycling again. One is hot in-place hot recycling, cold recycling. And as hot, you have in-place recycling or central plant recycling. In cold recycling, you have cold central plant recycling or cold in-place recycling. You can mill the entire material, and that is called the full depth reclamation. What is the final benefit? I am reusing the material. I am reducing virgin aggregate consumption. I am extending the life of the pavement. I am improving the property of the material. So reduce, reuse, recycle, and reuse the material is going to be the mantra of the years to come. When the material is, when you are adopting a hot mix as per recycling in a central plant, what are the defects that can be addressed to? When there are defects that are attributed only to surface, like deformation, cracks, patching, you can mill the top layer. You can take a core and check to what depth the crack has propagated to the top, or to what depth the rutting has propagated. It may be 20 millimeter, 30 millimeter, or a 40 millimeter. You mill chop off the 40 millimeter alone. Use this milled material along with the virgin material and reuse it again. But the usage of the wrap depends upon the mix properties as well as type of plant. This is what I told, the requirement of your expertise. I'll come to the issue. So you talk about the hot mix, you allow the virgin aggregate here, you pump in the wrap here. This material wrap has got bitumen coated aggregate. It's already aged. I don't want to heat this again. So what I will do is I will heat this virgin aggregate. This virgin aggregate will in turn heat the wrap. There's no direct flame heating the wrap. So what dosage of wrap can be heated by this virgin aggregate? This is in the ratio of 70-30 or 65-35. Then this 65 or 70% aggregate will be able to heat this 30 or 35% of the wrap. If I increase this 35 to 40 or 50 and reduce this aggregate will not be able to heat this aggregate. So that is the plant limitation as on today. Now we have the double barrel drums available, wherein I don't heat the wrap material. I allow the material here, virgin aggregate here, heat them with a flame hot gas stream, and take them, pump the material to the outer shell. There are two shells, one above the other. It is sent to the outer shell. In the outer shell, I pour the bitumen, wrap is allowed. I pour the bag house fines that are required. And then by this process, I will be able to increase the dosage of wrap. So technology is available. How the materials are behaving is again another research area. But in-place recycling can be done when there are corrugations, surface rutting, longer-term slippage crack. So but it's something like an equipment train. You need a huge space. Urban areas, impossible. Rural highways, multi-lane highways, possible. So decide what the pavement warrants. If the defects are confined only to the top, you can go in for a hot in-place recycling. It's something like an equipment train. You heat the layer. So you heat the layer 30, 40, 50 millimeter. You mill the material. To the milled material, you add virgin aggregate, pave it. So as the equipment train passes, you get a finished surface. Heater, scarifier, and filler. This is what we did in NH45, which is Chennai to Dindivanam. It's done for nearly 20 years. By now, it is 2004. Now it is 17 years. The pavement has been maintained by hot in-place recycling. So this is from Hitachi. They heat the surface. It can heat up to 30, 40, 50 millimeter. You mill the material, add virgin aggregate, lay it back. The finished surface is possible. Hot in-place recycling will result in sustainable engineering. Recycling can be in a central plant, wherein there are cracks, fatigue cracks, or there can be a problem with the base course also. Remember, in-place recycling of hot cannot address problem in the base layers or sub-base. But in the case of cold mixed recycling, I can mill the entire layer, bituminous and granular. I can add a foam bitumen. What is the foam bitumen here? It is done in cold in-place recycling because of rutting in the base courses, but it will require curing for some days. For hot bitumen, if you inject water, inject air, the bitumen foams. This will try to spot weld the milled material and can form a good base course. So the milled material, I add bitumen, I add water, I add air. So this material tries to rejuvenate the material and can form a good base course. We did this for the first time in 2011 in Chennai, Tada. I did the mix design. It's 10 years old, no failures, no distresses. The pavement is performing wonderfully well. So you can either mill the layer and provide a patch. But if you do this patch will propagate to the top. You need an ultra thin friction course here. I think friction has not been considered at all in design today. But with the Nagpur-Pune expressway being constructed for a design speed of 150 kilometers per hour, skid assistance measurement will be the future of a need for the country. So ultra thin friction course can be designed and constructed. Again, another area for research for the researchers. We can do this process, cost maybe $30. I can mill the bituminous layer which is cracked and replace the asphalt layer. This may cost nearly $45. I can also mill the bituminous layer and the base coats, above which I can construct a granular layer and a hot mix asphalt, which may cost nearly $42. I can mill the entire layer, reuse the material, stabilize with the bitumen, it may cost $24. So if you compare all these in terms of constraint cost, coal recycling will be the cheapest. Even when you want a summary of the rehabilitation, you find that bitumen stabilized material with coal in-place recycling will be sustainable, long-lasting, reduce initial cost, and also reduce life cycle cost. It's another highway which has to be rehabilitated. The material was excavated. Lumps of rock cannot be reused. It will damage the lower layers. So this is not sustainable. You cannot take the material to a central plant and do that. But you can mill the material to any thickness that you need. This can be fed to a hot mix or a cold mix, milled and dried. So up to 330 millimeter, it can be milled without disturbing the integrity of the geometric profile. Our 230 millimeter material was milled. This is how a milled surface will look like. So they did this exercise. Rehabilitation was done either with the bituminous layer or with the base course also. We found that 3,000 tons of milled wrap was generated in a 4-lane highway. They require 100 truckloads to dispose the material. So the option is not to throw the material, reuse it again. So different options are available. They considered the mill of the base course on the bituminous layer, and this bituminous material was laid here. The benefit we consider runs to several crores of rupees. So we started the Chennai Tada in the year 2011-12. Today, several roads are being constructed using this coal recycling technology. So we find that this is a highway which failed prematurely in 3 months. 40 kilometers constructed, spending 2,400 crores. Payment failed in 3 months. It's 6 years by now. The payment deterioration distresses are like this. What should I do now? So you can see the core samples on the bottom. So they try to mill the material, remove, recycle, and relay it back. By doing this process, they brought in 110 crores of rupees. The cost of rehabilitation is nearly about 300 plus crores. They have brought in the savings of nearly 110 crores by reducing the virgin aggregate consumption, reusing material, and after adopting coal in-place recycling. So this again is sustainable engineering. So in another case, we find that when they recycle 170 millimeter of a binder course, the overall cost is nearly about 90 crore rupees in that project. So cost comparison, there is about 18% savings because of reusing material, zero heating of the aggregate, emissions are minimal or no, so it's a greener technology that can be adopted. Coal recycling will be the future innovative technology because it reduces the cost of material disposal, transport volume, resource consumption, binder usage, shorter consumption period, and overall cost. So we should resort to sustainable pavement engineering by adopting coal mix. I strongly believe the future of Indian highways is on use of geosynthetics. They are cellular confinement systems. They have perforations. They'll enable permeability, horizontal permeability, as well as vertical permeability. The material fill layer can be dry. With the result, the load carrying capacity is much, much better. They are ultraviolet stabilized with carbon black, so they can last longer. I did an exercise for a project in Maharashtra, which the soil was very weak in a Gobind dairy. So they spread the geocells. After that, it was filled with aggregates, and then you can compact. I was talking about the marginal aggregates. Marginal aggregates can be filled up here. So by this process, I demonstrated that instead of providing 975 millimeter of pavement thickness, costing 2,635 rupees per square meter, I can bring down the thickness from 975 to 520 by using geocell in the base and subgrade. I can bring the cost from 2,635 to 2,450. Even for higher CBR, I demonstrated that instead of 650 millimeter, if you use a geocell in the base and subgrade, you can bring down the thickness to 340, and then can bring the cost from 1,900 rupees per square meter to 1,815 per square meter. If this can last for 14 years, my pavement design can last for 20 years. So there are different benefits. Reducing the thickness, reducing the budget aggregate consumption, improved performance, longer life, lesser maintenance cost, lesser road user cost. This is a project of a road in Gujarat. Road was bad. It's about in the city of Gujarat. The presence of creek makes a high groundwater table. soil was soft soil, severe was less than 2. That's how the soil actually is soil. What is to be done? How to ensure a sustainable construction? So the problems can be solved by using geosynthetics, geogrids. They use an extruded geogrid here. They have a non-woven geotextile, a road mesh. So this geosynthetic has got different functions. It serves the function of filtration, confinement, drainage, and also to prevent the refraction cracking. So geosynthetic is also as a separator. So 4 functions it functions. So you should use the geosynthetic as a drainage layer, as for confinement, as a reinforcement, as a separator. You can bring in sustainable pavement. Even coir can also be used as sustainable low volume roads. We adopted this in several roads in Tamil Nadu and Kerala. Where it's again the function of the geosynthetic is coir geotextile is separation, drainage, filtration, and reinforcement. The layer has been laid, and we found that thickness can be brought down from this thickness of 175 per 75 to 25 to 200 millimeter. Instead of having 200 millimeters, 250 millimeter, I can bring down to 225 millimeter, reducing the savings in aggregate quantity of 200 cubic meter or 100 cubic meter per lane kilometer. So sustainable engineering, that you can also use it for rainwater erosion control, protection of embankment. So I think it's time that more and more sustainable materials are to be adopted. I think we can also think in terms of concrete pavements because they have a low deterioration rate, longer life, lower thickness. But only problem is under overloading conditions, they may prematurely fail. They get polished. Stage construction may not be possible. But considering the advantages will be higher benefit than the limitations, we can go in for a concrete pavement. Sustainable, no deflection, less fuel for construction, lesser demand for virgin aggregate. It can also be 100% recyclable. Low energy footprint, optimal texture depth, quieter pavement is possible with a whisper concrete. Again, another area for research, whisper concrete. Lower life cycle cost, again, another area for research. Predicting the performance of concrete pavement, working of the life cycle cost. Long-term effectiveness are to be studied. I think the future is again, sustainable pavement can be in terms of precast concrete pavement. My dream is that today the road should not be there. Tomorrow morning when you come, your finished concrete pavement should be there. Is it possible? Possible. Precast concrete pavement technology is gaining importance. You can precast elsewhere, store it in a central plant, bring it, assemble it at the site. So you can post-tension it at the site. Example being done at Nagpur, currently now in Nagpur. We are doing, but we are fine-tuning the design in terms of joints, how to have a double bar, how to ensure a uniform base course. Constructability issues are there. We are trying to sort out this issue, but definitely precast construction concrete slab is a order of the day. In case of urban roads, where the roads are full of cracks, rutting, patchy, you can mill the layer, you can introduce a concrete pavement here. So the thickness of concrete pavement for a white topping will be lesser than 200 millimeter. Remember, when the thickness is lesser, your joint spacing should be lesser. So you can find a 6 feet slab width, 6 feet slab width. I would say that 1.8 meter, that's what they are talking about. I may say even 1.5 meter. So in the case of conventional concrete pavement for highway, it can be 3.5 meter by 4.2 or 4.5. Thickness is 300 millimeter. But when you do this white topping, you can reduce thickness to even 150 millimeter or maximum 200 millimeter. But slab size should preferably be square, 1.5 by 1.5, 1.8 by 1.8 meter. You cut the depth to 1/3 the depth, crack will form of its own. Thickness is assigned to the composite pavement. You can do a mechanical analysis. You can do an optimal joint spacing. So the slabs are smaller, feet by 2 feet. The load distribution is different. It's not as having a slab action. So it has to be decided differently. This is again another area for research. But there is an optimal thickness based on life cycle cost. Initial thickness may be lower, cost may be lower, but maintenance cost is higher. But a thickness may be higher, but maintenance cost is lower. So you have to come out with an optimal thickness based on the life cycle cost. There's again no one size fit all defined. Optimal joint spacing has to be worked out. We find that the pavement will warrant the maintenance, different maintenance of the preventive, minor rehabilitation, major rehabilitation. It will work out the life cycle cost. We look at the life cycle cost for a pavement with the bituminous pavement. These are thicknesses that are required. It requires 35 millimeter, 40 millimeter bituminous concrete, 100 millimeter dense bituminous macadam, 250 millimeter wet mix macadam, and 200 millimeter granular subbase. Alternatively, I can reduce thickness by rigid pavement. Margin aggregate consumption is reduced, and life for 30 years I have decided. When you look at the margin aggregate consumption that is required for a four-lane bituminous layer, 24,000 metric ton per kilometer is required, whereas for concrete, it's only 21,000 metric tons. So 3,000 metric ton per kilometer can be saved initial construction, but for the life cycle, it will be much, much more. So there will be a significant reduction in the aggregate consumption as well as the cost. So the challenge is selection of the pavement type, realistic design, optimal thickness that has to be arrived at, periodic monitoring so that performance prediction models can be developed, quantify the effectiveness benefits of preventive maintenance, which can again extend the life of the pavement, assess the maintenance requirement so that appropriate pavement type can be selected. Importance is the quality of the construction, new material and design will be the challenge. Issues are that prediction of the performance of alternate designs. How do you recycle the concrete pavement? Joint construction is another issue. Pointed pavement is again another area for research. Whisper concrete. Instrumentation so that you can relate theory to practice. Your model can be verified. Field validation is also required. So the contract award process has to be modified because we can bring in sustainability in a tendering process. We have to work towards the life cycle cost and awarding the work, not based on the L1 or the lowest initial cost. Different types of concrete payments are possible. It's not one type. Jointed plain concrete pavement, continuously reinforced concrete pavement, fiber reinforced concrete pavement, precast concrete pavement, different types are possible here. So bottom line is life cycle cost. We need more and more green highways, taking into account the locally available material, natural slope, recycled material, tapping of the water, groundwater water recharging, better warm mix asphalt. Considering life cycle cost, that we look for sustainable pavement engineering is greener highways. So need a research, before I conclude, is that need a research is theory to practice. Lab and field studies are needed, but duly considering the construction variability and the quality of construction. New materials are to be introduced, arterial aggregates are to be developed. We need construction of test tracks with their alternate designs, monitor the performance. We should be able to predict as how these alternate materials will behave. What are the constructability issues? We have to modify the bid documents so that these sustainability issues are given, a weightage is given to sustainable design before you award the contract. We need a capacity building like this training program wherein you educate the engineers on the issues of alternate bids evaluation, a feedback mechanism as how the alternate designs are performing. Sustainable road infrastructure requires new materials or alternate materials or artificial materials. Using these materials, sustainable pavement engineering, pavement design requires an improvement in the design. Alternate designs with these new material properties has to be developed. Accelerate the construction is what is looking for. Will it be possible like a precast construction? You can accelerate the construction rate. Maintenance requirement can be proactive or can be preventive or corrective. We need to develop specific schedule of rates for the new materials. We need to evaluate the performance to the cost of construction to the economy. Life cycle assessment is going to be another order of the day. And more importantly, sustainable payment system warrants environmental impact assessment and considering that parameter in the payment evaluation, payment construction, payment design process. So make the world more beautiful. You should leave the world more beautiful than you have found it when you were born. That is sustainable engineering. Then you have done some service to existence. So make the quality of the life of the people happy. But it is impossible to make sustainable environmental challenges unless there are changes in people's behavior, values, philosophy of life. First, the top management should understand sustainability and its importance. They should change the contract bid documents. They should adopt new technologies in material. So it needs a change in behavior. And once it does, we will be able to construct more and more sustainable payment structures. I would like to thank the IRC, the Hazard, Professor Rajib Malik, John D'Angelo, and Brian for sharing the material which I have used extensively in my slides. Thank all of them for that. So thank you very much. I think I finished the 1 minute late of the allotted time. Thank you very much for your patient hearing. Now I'm available for answering any of your questions in this subject.
Sir, there is one question in the chat box in question answer section. Near the tab of participants, we have a question answer Q&A section. May kindly refer. 1 or 2 questions are there.
I'm not able to see only one question more where it comes. It comes a question and answer.
Yes, sir.
There's a chat box where they're very informative and interesting session only. Is there any other question is there?
Please clarify.
Yeah, no. Are there any question? You can read the question. I'm not able to read the question.
Yes. Professor Sudarshan, if he is available, he may directly.
Yeah, that's all simple. Yeah, you can ask directly. I can understand you better.
Professor Sudarshan, JS, who has written that question, may kindly. He has written the question. Please clarify why sustainable concepts are not reaching to the society and not gaining quick popularity. Not gaining popularity.
No, we have. See, all this time we have been thinking of available material. We have never thought about the requirement of the sustainability. Now only we are bringing in the issue of sustainability here. People have never understood the importance of that. I think now only creating a interest in the minds of people. I think over a period of time it will come. I think, but again, unless the top management understands, it's very difficult to bring this into the picture. So it's only the lack of awareness that is preventing the adopting the sustainable engineering. I think it's time that it will come over a period of time.
And one more question is that same person, Professor Sudarshan ji, if you are available, can you please elaborate the question? Okay, I will read.
Yeah, you can read the question. Yeah.
Even plastic also takes several years to gain popularity. Similar.
Yeah.
So his observation is that even plastic also takes several years to gain popularity.
Tell again, read again.
He has written that even plastic has taken so many years to gain popularity.
Yeah, right, yeah. I was thinking that he is asking about plastic and sustainability. I think plastic is also another issue of environmental hazard which we are facing in the country. But what we have found successfully is that we are using the waste plastics in bituminous layers. IIT has come out with a new code of practice in 2019, wherein we are able to make use of the plastic in the bituminous construction. I feel that it's also possible by reducing the plastics in the environment. We can take it, shred it, use it in bituminous construction. The environment gets benefited by get rid of the waste plastic. Road gets benefited because it extends the life, reduce the moisture-induced damage, and therefore we can reduce the maintenance requirement. So I feel that plastic, it has a blessing in disguise. It is causing a non-problem, but on the other hand, I can improve the life of the pavement by using it in the bituminous layers.
There is one more query. Is there any IRC code specification, especially for using industrial waste or recycled waste in road construction?
Yes, IRC 120 is on recycling. IRC 120 is on recycling of the materials. You can refer to that.
So any other participant may kindly unmute and ask the question. Any other participant, please?
Good morning, sir. My name is Sanchit. First of all, this was a very informative session. Sir, I had one query. I recently read in the budget announcement of the government that they are planning to take all the roads to concrete pavements. And regarding asphalt one, they take a lower as far as I've read, the maintenance cost for vehicles and everything is lower when we go for bituminous pavements. do you think this will have any implication on overall economy if like everyone switches to concrete pavement?
That's a good question. I think this is a bit bold news because I think if you go to YouTube and listen to Mr. Nathan Gatkari, this is what he told maybe 2 years back. I participated in a session with Mr. Nathan Gatkari maybe last month. He said that it is now the concrete industry cartel that has pushed up the concrete cost, cement cost very much. Now, concrete payments are not sustainable. So now the government is not telling go for concrete payments. You have to, I feel that my simple suggestion is that even bituminous payment are quieter, calmer, smoother, and better. But only thing is how to make this bituminous payment last for 50 years. That is the challenge. As I was mentioning, simplest way is to reduce the thickness by stabilizing a subgrade. The number of commercially available stabilizers are available. I think I forgot to make a mention about that. If you are interested, you can go to Krishnapatnam Port Connectivity Project. There, they have constructed a pavement without aggregate. Believe me, they have constructed a pavement without aggregate. It is only soil, cement, and a stabilizer, on which only 30 millimeter thick bituminous concrete has been laid. It is 4 years by now. I have all the evaluation report. More than 3,000 commercial vehicles are plying per day. No crack, no rent, no distress. So it is possible to construct alternate pavement. It need not be concrete. Alternate designs are possible. So the government is now of late is not advocating concrete pavement. So you need not worry about that. That will never, I don't think that will come through. And secondly, as I was mentioning, there is nothing like a one-size-fits-all design. Concrete is not the solution for all pavements. Depends upon location to location and project to project. One has to evaluate alternate designs and then only design concrete pavement. Otherwise, concrete pavement may fail. A good example is the Mumbai-Pune Expressway, 20 years over. How is the performance? If you ask me, performance is good. I don't say it is bad. Other cracks? Yes, there are cracks. Maybe of the 1 lakh slabs that are there, maybe more than 1,000 slabs would have cracked. That's some lessons we have learned as why it cracked, what is to be done. But generally, if you look, the performance is good. Maintenance cost is low. Therefore, there's no doubt concrete pavement will warrant longer life, lesser maintenance cost. But need not be the only sustainable solution for all highways. So Mr. Nitin Gadkari had changed his version for use only concrete to anything that you adopt. That has changed. Any other? I think Sudarshan posed a question.
Yes, sir. In chat, there is one question. Is there any pre-treatment required for we provide geotextile fibers? Is there
I don't think that. No, it can be straightly taken. It can be straightly taken, stretched tight, and then filled. It can be filled. It can be geogrid. It can be anything. I see. I think I did make a mention about that. Because of time limitation, I could not show other slides. These geogrids can be used in subgrid also. If you can use the geogrids, maybe at different depths, you can increase the strength of subgrid. No need of any treatment. So if the subgrid strength increases from say 5 CBR to 10 CBR or 15 CBR, your thickness reduces drastically. Performance improves drastically. I feel the future of the Indian highways is on use of geosynthetics. Even today, I have a meeting with the Kerala engineers, KIFB, wherein we want to adopt alternate technologies. One technology that we are going to advocate and practice on a larger scale is use of geosynthetics in pavement layers. So somebody who wants to do a PhD can study what are the geogrid specifications that are to be adopted, what depth for different soils, at what depth they can be placed, what is the improvement in the strength, and more importantly, how to use this composite structure with a geosynthetic material in the layer in the analysis. What people do is, I have done a plate load test and this is strength that I got. No, geosynthetic is a different material. That means you should use Plaxis. It can be Plaxis 3D preferably. Consider geosynthetic as a different material. Will it be subjected to the fatigue effect? Maybe. Will there be time-dependent deformation? Maybe. I think these are studies which will be of interest to the country. We look forward to such research publications from you and use an analytical design of pavement with geosynthetics using advanced computational methods, not by layer theory. It cannot function as a layer theory. But definitely no treatment is required if you want to use a geosynthetic. It can be just laid like that. Yeah. Any other questions?
So one question is written
Yeah.
that is there any rating system available for payment like lead, BREM, etc.?
Yeah, that's a very good question. I think as on date, that's also, I would say that this is also another area for research. There's a lead certification is possible internationally. You can go to lead website and you can see there are available there. But for the Indian context, it is not available. There's only one ISC code on the environmental impact assessment that is available, but never it's not available. As I was mentioning, if somebody can work out on this area and develop guidelines for rating of projects based on the benefits that the technology will bring in, and then consider that weightage while evaluating alternate designs, then you will be definitely doing a significant contribution to country's economy, country's road infrastructure. I appreciate the question. I think that's a good area for research. As like a green building norms, we need green pavement norms. And this is an area for research somebody can develop. What are the benefits? What are the quantified economic benefits, social benefits, environmental benefits? All the three can be considered. It's a good area. Good question.
Any other participant, if he or she wish to ask the expert?
I think even otherwise it's not it's only the beginning, it's not an end. We have just met for the first time. Some of you might have attended my lectures earlier. Nevertheless, if you have any questions later, you can post the questions to me. My email ID is in my presentation. The presentation will be shared by Dr. Praveen Kumar. If you have any doubt, any question, because on day in and day out, I have been teaching for the last 41 years. So thousands of students are there. Every day I get questions, mainly from the army officers who did their MTech and PhD with me. Every day they have problem, they post to me. I also learn the process. That's why I derive pleasure in that. So when you have any question, any problem, anywhere, on anything in payment engineering, you can post me a question. If I know the answer directly, I will tell. If I do not know the answer, I'll consult somebody and get back to you with a solution. But I promise you that you will get a response of a sustainable engineering, a feasible solution, which can be adopted and it will work. Not on paper, on ground it will work. I can give a solution. Yeah.
With this, I take the opportunity to express my gratitude to the, I think, legendary professor in the country in highway. I should say that this has been a thorough treatise today, 90 minutes non-stop, and rather 91 or 92 minutes. And we are grateful that your talk has motivated many young minds today, as you have been emphasizing on the what can be done in the new research areas. And of course, your talk motivated all of us, and your emphasis on life cycle cost is well taken. And I request the participants to express their queries as he has promised to answer them throughout, not in this 5 days, but after that also. So with this note, I express my gratitude to you, sir.
Thank you. But before I conclude, I think that many of you may be working in concrete, may be working in pavement, but almost every college will have a good concrete laboratory. So I would suggest that the research in concrete is easy to do for those who want to do a PhD. I would suggest that you just Google and find out concrete road map. You just Google with the words concrete road map. So there are two books, two manuals available. It will give you a number of research problem statements, starting from material to design to construction to maintenance to management. So you can pick any of the topics from that concrete roadmap. And because you have a laboratory, you can cast a slab, you can cast a beam, you can test it fatigue in the laboratory. It becomes easy for you to design alternate pavements with the fiber reinforced, different fibers. We can study different materials, different cement, you can have different strengths. So it becomes easy to contribute to the research and publish the paper as well. So you please look at the concrete roadmap and fine-tune, zoom your research area, and then start your research work and publish your work, and that will be a win-win situation. You'll be recognized in the country, not only the country, around the world. Secondly, you'll also be contributing to the available research literature, and that is what we expect from the students and the teachers. So thank you very much, Dr. Praveen, for inviting me and spending time with me. Thank you very much. Yeah.
Thank you, sir. From RTU, the Sun Technical University, yeah, also I thank you so much, sir.
Yeah. Thank you, Arvind. Thank you.
Thank you, sir.
Thank you.
Sir.
Thank you. Yeah.
So with this, I stop this session and request the participants